picking up from Saxon's Trigonometry, Lesson 1, beginning with Section D on page 5. This is about betweenness, tick marks, and assumptions. Now, in the last lesson video, you saw me use at the end some markings which indicated that two angles, vertical angles, were the same. We are going to add to that and say that if I put a single line and a single line, those are indicating tick marks. And that is to be different than, and again, for this one, it's going to be two angles are written that way. If it is a line, and I'm trying to say that this line length is the same as this line length, and this one is the same as this one, I might designate this set with one tick mark and this set with two. I can use 3 lines. I can get through any Roman numeral, but typically we don't go past 4 usually at the most. Most of our diagrams will not need a lot of things listed as the same. So if you needed a third line, this one is the same as this one, then they might share 3 tick marks, and I could, like I said, use a 4, maybe up to a 5, but typically these are the ones that you're going to see. And then it will work the same in a series of angles. So if I mark this angle the same with 1 tick mark, where they're vertical, I know that they have to be the same. If it's 2 different angles being drawn, I don't know for sure that they're the same unless they are marked with identical tick mark amounts that they are the same. I cannot make that assumption. And I skipped over to get to tick marks. They're part about betweenness. So their example in the book shows a line with dots A, C, and B. And these are all in a line. They are collinear because they're in the same line. And I can definitely say that C is between A and B because A is on one side of it, B is on the other. If I label another point M anywhere, I cannot say that M is between C and B because they are not on the same line. So in order to know betweenness, they have to share a line. Even though it looks like M is falling somewhere between C and B, it's not on the same line. Now, moving on to page 6, I said before that there are certain things that we can assume and certain things that we cannot when we were doing the other video on undefined terms. So here is a list of things that you can assume and things that you cannot assume on diagrams within the Saxon book. So what you can assume is listed in the permissible column. Straight lines are straight lines. So if it, for all intents and purposes, it looks straight, you can assume it's meant to be straight. Collinearity of points. If the points look like they are on the same line, they are intending them to be on the same line. You can also assume relative location of points, that C is between A and B. That's its location. And then that falls to the same betweenness of points. C is between A and B. What you cannot assume in a diagram, if I draw this, you cannot assume it's 90 degrees, even though I'm doing my best to draw it to look like a right angle. I cannot assume it's a right angle. If I see the 90-degree symbol in there, then I know it is meant to be 90 degrees. If I draw these 2 lines and I make no indication, no tick marks, I cannot assume they are the same length unless they're labeled with the tick marks. The same thing applies to equal angles. I cannot assume that 2 angles are the same. Relative size of segments and angles. I cannot draw that symbol without the 90 degrees and assume that it's 90 degrees. It might be 89 degrees. I must not assume a measurement of a line or an angle. And finally, I cannot assume perpendicular or parallel lines unless they are marked, or I'm told in a paragraph that they are the same. So they show you a diagram picture there near the top of page 6. And it shows you in the list of 1, 2, and 3 the things that you can assume, and then continuing in 4 through 8 the things that you cannot assume. Now into section E, which is triangles, we need to name some triangles. If I have this triangle and all of the corners, edges, angles, I'll get the symbol or the term there in a moment, are labeled as 60 degrees, then I know that all 3 of them are the same, and we would call that equiangular. There we go. And that would mean equal, because it's there in the term. Oh, there's no L in that. Sorry, hang on. EQUIA. My goodness gracious. IANGULAR. There we go. Equiangular. Whew. And that means all sides are the same in degrees. The only way that you can have an equiangular triangle is if they are 60 degrees, because every triangle is worth 180. 180 divided by 3 must give you the 60. So you would never have an equiangular triangle that would be 59, 59, and 59 degrees. It's just not going to happen. All right, what happens if 2 of the angles are the same, and again, those need to be labeled, then we call that isogenic. Not a term we use a lot, but it indicates that I have 2 angles in a triangle that are the same. If I have one 90-degree right angle in the triangle, we call it a right triangle. If I have 3 angles that are all acute, but not necessarily the same in degrees, then we call this an acute triangle. All 3 must be less than 90. And if I have one obtuse angle, then I will call it an obtuse triangle. And this is the obtuse angle there. Let's go back to the right and the obtuse angles for a moment. If I have one angle that is more than 90, then that leaves me less than 90 degrees for the other 2. So the only way I can actually draw a triangle is if these are acute. The same thing happens with the right triangle. 180 minus 90 leaves me 90. These 2 must total to be 90 then, so they must be acute, less than 90 degrees. Okay, on page 7, we move to naming these triangles not by their angles, but by their sides. So if we have an equiangular triangle, it will also be equilateral, because all of the sides will be the same length. There is a rule which says that the side opposite a degree will always be the same if it is opposite the same degree. So if these are both 60, these 2 sides must be the same length. And since this one's also 60, this side must be the same length. Therefore, it will be equilateral. If we have 2 angles that are the same, therefore it's isogenic, that means that this side and this side opposite those will be the same. And this is the term that we use more than isogenic, which is isosceles, because we tend to name this one by its sides rather than by its angles. And part of that is because I think it's easier to say, and so it's just kind of gotten down to that. And now, not renaming these because they don't have a specific name for their sides. If you have a triangle and all sides are of different lengths, then we call it scalene. And I will continue on to section F, page 7, which is transversals, alternate and corresponding angles. These require me to have parallel lines. So one of the ways that the Saxon book will indicate that lines are parallel is that they will do this little, it's not really an arrow, it's kind of a darkening within the arrow, or a symbol sort of like that, that will indicate that these are parallel lines. And then a line cutting through them is called a transversal. this transversal line has created vertical angles. So if I choose to label this one A, then I know that its vertical will also be A. If I label this one B, its vertical will be B. I know that A plus B forms a line, so it equals 180 degrees, whether it's these two, these two, these two, or these two. They all form a line. All right, and in the title here, you know that you are heading to a term alternate and then corresponding angles. So what are alternate exterior angles? Well, alternate is going to indicate the opposite side of the line. So if I'm talking about this A, the opposite side of the line is going to fall somewhere here. And since I said alternate exterior, exterior is indicating the outside of the parallels. So this one was on the outside. So this is its alternate exterior angle. If I move to this A and I want to talk about its alternate interior angle, go to the opposite side but remain inside the parallels, it's A. It's also A because they are vertical. Okay, so now to get the term for corresponding, that means I am combining a vertical and an alternate set, and that will make them corresponding. So this B verticals to this B and would alternate to this B. So I would say that this B and this angle B, they are corresponding angles, therefore they must be the same. So I don't have to go through the alternate, or the vertical and the alternate combination. I can just jump to this one is the same as this one. They are corresponding. And just to finish filling it in vertically, that makes this B, or B to B being corresponding, A to A being corresponding, and so forth. That gives you the terminology on the remainder of page 7. Into page 8, they give you more of the alternate and the correspondings, and then it moves into box information. Whenever you see box information in the Saxon book, it is indicating a rule of some sort, which you will probably want to put in your notes for safekeeping and reference to quickly be able to access it. So in this first set of boxes, there are 3 rules: properties of parallel lines. If 2 parallel lines are cut by a transversal, each pair of corresponding angles is congruent. Very similar to what I just said, if 2 parallel lines are cut by a transversal, then each pair of alternate interior angles are congruent. And finally, if 2 parallel lines are cut by a transversal, then each pair of alternate exterior angles are congruent. Then the next is conditions for lines to be parallel. And in that box, it basically says if you have alternate interior, alternate exterior, or corresponding angles, you are guaranteed that these must be parallel lines. And then on the top of page 9, it shows you another type of problem that they can give you. And this uses 3 parallel lines and a transversal that cuts through in 2 different places. And if, as in their example, they labeled this 3 and 4, and here as X and 6, what you do is set up a proportion just as you see it here. So 3/4 equals X over 6. And you solve a proportion by cross multiplying. So 3 times 6 equals 4 times X, which you write as 4X. 3 times 6 being 18 equals 4X. Final step, divide by the 4, so X equals 18 over 4. But 18 over 4 needs to be reduced down by 2, so X equals 9/2 as the final answer. And before going into section G, we'll stop this video and do that section in another one.